Hello everyone and a very good evening. Now before we start the session, quickly let me know if I'm perfectly visible and audible to everyone out there or not. Quickly you can write in the chat window and I'll understand. Sushmita, good evening. Deepak, good evening ma'am. Yes. Quickly you can write in the chat window. Hema, hi Hema. Darpan, I'm Aradhana, I'm new here. Yeah. Aditi, hi ma'am. Param, hello ma'am. We have Yazini here. Yes. Rudra Jyoti is here. Devi, yes, good evening. Alright, so there is no glitch at all, so we can continue. First of all, welcome to all in yet another wonderful session. So as you would have seen the title of the video by now, right? So today we'll be discussing questions from the chapter Triangles and Lines and Angles. So both the chapters are from geometry, yes? So generally I've seen that students have this phobia from geometry. They don't like geometry much, right? Because sometimes I've seen that they would mug up the questions, they would try to cram up the questions, but it's not a theoretical subject. So all you need to do is, I would say, you should know the theorems well, right, and your properties, right. If you know these things really well, trust me, this chapter, these geometry chapters would be really easy for you. Alright, so without wasting any more time over here, let's start the session. Let's first take a look at the contents of this chapter. Right, so these are the contents of the chapter, from the chapter Lines and Angles first, and take a look at this. There is no change in the syllabus for this chapter, so we need to study all the concepts that you can see here: basics, terms and definitions, intersecting and non-intersecting lines, pair of angles, parallel lines and transversal angles and property, and exterior angle property. So this is from Lines and Angles. Now let's take a look at the content from the chapter Triangles. So these are the topics that we have, and again, there is no change in the syllabus for this chapter also, so we need to study all the concepts that we can see here: the intro, criteria for congruence of triangles, which are SAS, ASA, SSS, RHS. You should know which criteria we can use, right? That's really important. Deepak, I love geometry. Great. Yes, Savita, good evening ma'am. Jayasri is here. Hi ma'am, today I had mathematics exam about geometry, theorems and simultaneous equation. It was very easy, right? Okay, Nihal, great. Good evening. Ashish, thank you, ma'am. Shreya, it's one of the very easiest chapter, yeah? Okay, great. So, and we have sides opposite to equal angles of a triangle are equal and angle opposite to equal sides of a triangle are equal. Again, I am saying the same thing, that remember the theorems and the properties. It's given in your NCERT books. So, even if you don't know what all theorems are there, what all properties are there, you can just go through your book one more time. Alright, so without wasting any more time here, let's start the questions. So whatever questions I'm going to discuss here, they will cover all these concepts really well. So get your pens and papers ready and solve the questions along with me, and I want you to report your answers to me. And if you do not know how to solve a particular question, that's absolutely fine. You can solve with me, you can follow me. Alright, so here we have the first question. Alright, so this is the difficulty level meter that you are going to see in every question. So if you see two greens over here, that means it's an easy one. If you see yellows over here, means it's a moderate one, and orange and red denotes that it's a difficult level one. So depending on the difficulty level of the question, we should know how much time we should devote on that question during the exam and how much time we should take to prepare those questions, right? Alright, so let's start with this. So an exterior angle of a triangle is 105 degree and its two interior opposite angles are equal. Each of these angles is. So basically we have to find out the measure of each of these equal angles. We are talking about a triangle here. This is the triangle that we have. Okay, I can see that people have already started giving answers. Yes? Okay. I'll tell you the answer, what the correct answer is. So here an exterior angle of a triangle, let's suppose I'm talking about this exterior angle, right? And its measure is given, that's 105 degrees, and it's two interior opposite angles. What will be the interior opposite angles here? Right, interior opposite angles, let's suppose these are the two. They are equal, right? Not this one, because it is right adjacent to it. So according to exterior angle property, we can say that in a triangle, the exterior angle is equal to the sum of two interior opposite angles. This property is important, right? So make sure that you write the properties that we are using. Alright, so using this property, I can say that the sum of these two interior opposite angles would be equals to the exterior angle, that's 105 degrees. That would be equals to 2x equals to 105 degrees. So x would be equals to 105 divided by 2. Simply we would get 52.5 degrees. That would be the measure of each of these equal angles, which is basically option B. Yes, Hema, absolutely. 2x is equals to 105. Shreya, B. Rajaraman, Deepak, yes. Jayashree, yes. Option B. Then Jayashree, yes. Option B is there. All right. So the value of x, which is option B over here, that's 52.5 degrees. That's the right answer. So this was a very simple one. So gradually I'm going to increase the level of the questions as always, and the difficult ones are saved for the last, you know it. Let's move to the next one. So if AB is parallel to CD, is parallel to EF, and PQ is parallel to RS, and angle RQD is equals to 25 degrees, and angle CQP is equals to 60 degree, then QRS is equals to what? So here in this question, it's a very good question. You see, in this figure we have got three parallel lines, this AB, this CD, and this EF, right? And here we are given that PQ is also parallel to RS. This is the PQ here, this is RS. Let's extend this to understand. This is PQ, this is RS, right? These lines are also parallel. Now we know one thing, when lines are parallel, then we know that, and they are intersected by a transversal, we say that corresponding angles would be equal, alternate angles would be equal, co-interior angles will be formed there, right? Okay. Now what we need is, we have this RQD over here. This RQD is, that's 25 degrees. Look at the figure carefully. And this angle CQP, this is CQP. This angle over here is 60 degree. What we need is, we need angle QRS. Now QRS is this much, this entire angle, right? Now this QRS, if you carefully look, this comprises of two angles. This angle QRA, right, this one, and this angle ARS. This comprises of two angles over here. Alright, so I can say one thing, that in this question, since this PQ and RS is parallel, I can say that here, this PQC, this angle PQC, and this angle BRS, this one, let's extend these lines. You can also make this figure in your notebook. It will be very easier for you to understand then. Let's extend these lines, and this is what? This is nothing but that's a transversal over here, right? It is intersecting the lines. So here this PQC is 60 degrees, this angle. So if this is the transversal, you can see that a Z is formed over here, right? Look at this Z. So whenever the Z is formed, then in that case alternate angles are equal, right? But here the alternate exterior angles are equal. See? These are two alternate exterior angles, the Z is formed over here, so this will also be equals to 60 degree. Now in a similar manner, what I can see here is that this angle DQR, this angle DQR, this is 25 degrees, and this angle QRA, this will also be 25 degrees, you see again a Z is formed. See, we can only use these properties like alternate interior angles are equal, corresponding angles are equal, and co-interior only when the lines are parallel and they are intersected by a transversal. Sometimes students do make this mistake that whenever it is mentioned in the question, only then we can use it. When it is mentioned that the lines are parallel, right? So here we can say that, as I told you, that this QRS comprised of these two angles, this and this. Simply I'll mention their values here. So this QRA is written as it is. This ARS, if you carefully look at this ARS angle is basically forming a linear pair over here with angle BRS. So in linear pair, we know that their sum is 180 degrees. So from here I can say that 180 degree minus angle BRS. Yes, using the linear pair axiom. So here let's put the values. QRA is basically 25 degrees over here. This is 180 degree minus 60 degree. That's the value of angle BRS. So we get 205 minus 60 degree, and at the end you would get 145 degrees. Let me check the answers now. Sushmita C, yes, 145 is the answer. Deepak says 145. Shreya, Aditi, Hema, Ramesh, Shukla. Absolutely. 145 degrees is the right answer for this question. So you see, this figure looked a little bit tricky, but solving of the question is not difficult if you know the properties and theorems and all well, right? So option C is the right answer for this question. That's 145 degree. Alright, let's take a look at the next one. If the angles of a triangle are in the ratio 5:3:7, then the triangle is. And this is an easy one. See the four options: acute angled, obtuse angled, right angled, isosceles triangle. Only I'll be able to tell this once I know the measure of the angles, right? And here we are talking about the isosceles triangle. That means two sides will be equal, so their opposite angles are also going to be equal. So two angles will be equal. So to answer this question, what I need here is I need the measure of the angles, right? Alright, so let's solve this. So we know that sum of all angles of a triangle is 180 degree, right? That's the angle sum property. Now let's assume here that angle A is 5x, B is 3x, angle C is 7x. So sum of all the angles is 180 degree. So let's add them up, equals to 180 degree. So from here you would get the value of x, that's going to be 12 degrees, right? But I need the measure of the angles here. So angle A, which is 5x, that's going to be 5 times 12, which is going to be 60 degrees, right? And similarly, we have angle B, that's going to be 3 times 12, that's 36 degrees, and angle C, that's going to be 7 times 12, and that is going to be 84 degrees. What I see here is that all of them, if you look at this, all of them are lesser than 90, correct? Lesser than 90 means it has to be an acute angle triangle. That means option A, Palak, Deepak, Disha, Sushmita, yes. Option A, absolutely. Shreya, tomorrow is my maths pre-board. All the very best, Shreya. I'm sure that you would do well. Yes, Aditi, Hema, Namita, Nidhi, Aranya. Right, so option A is the right answer, and I can see that all of you have given the right answer, so it's clear to all of you. So let's move ahead. Now in this question, we are given a triangle ABC. Figure is already drawn for us. AB and AC are already equal. These are the two sides, they are equal. Angle B is given, that's 50 degree. So what angle C is going to be? So this is an easy one, right? Okay, so we know one thing, that when sides of a triangle are equal, then the angle opposite to them are also equal. So angles opposite to equal sides of a triangle are equal. This is the property that we are going to use here. So using this property, I can say one thing, that AB and AC are equal. That means their opposite angles will also be equal. What are their opposite angles? So angle B is 50 degree. Angle C will also be 50 degree in that case, right? Angle C and angle B are going to be equal according to this property, right? So I can say that here angle C is also going to be equals to 50 degree, and you have to mention the property here, that angles opposite to equal sides of a triangle are equal. So writing the properties, so whatever step you are writing, mentioning the reason, mentioning the property with that is very important in geometry. So that's your angle C, which is 50 degrees, right? So I can say that option B, that's 50 degree, is the right answer for this question. Yes, Papiya, Hema, Shreya, yes. Facts wala, B50, C80. B50, we only have to find out option for our value of angle C, that's 50 degree. Absolutely, that's right. Disha, Aditi, yes. Subramanyam, Deepak, Nidhi, Palak, yes. Yep, yes. Option B, that's 50 degree, is the right answer for this question. It's pretty easy one, yes. Okay, let's move to the next one. So here in this question, we are given that triangle ABC and triangle FDE, these two triangles are actually congruent to each other. So congruent means the very first thing that comes to the mind is their corresponding paths are going to be equal, right? That means their corresponding sides will be equal, their corresponding angles will be equal. See, keywords are already given in the question, right? You just need to know, like, what information do you get from that keyword. AB is 5 centimeter, this is AB. Angle B is 40 degree, that's given. Angle A is 80 degree, that is also given. Which of the following is true? If you look at the options, in all of them, DF here is given, that's 5, and in two of them it's given DE is 5 centimeter. So first thing that we need to check for the measurement here is DF or DE. Third thing is the measure of the angles D, E, F and E. Okay, so we'll start from here that the triangles are congruent. So I can say that triangles are congruent, that means their corresponding paths over here are going to be equal. So I can say one thing, that this FD and AB are going to be equal, correct? Their corresponding sides will be equal. So CPCT means corresponding parts of congruent triangles. We are given that AB over here is 5 centimeter. So this FD should also be equals to 5 centimeter. So FD is 5 now. Okay, and we can also say that this angle E and C will also be equal. They are also corresponding parts of congruent triangles, right? So since I can say that from here angle E would be equals to 180 degree minus angle A plus angle B. How can I say that? Reason being, if you see here, angle A is 80 degree, angle B is 40 degree. According to angle sum property, I'll get the value of angle C over here. That would be 180 minus angle A plus angle B. And whatever value angle C has, angle E will also have the same value since they are equal, right? Alright. So I'm just going to put the values here. So 180 minus 80 plus 40. So what we will get here, the answer in that case is going to be 60 degrees, right? Because 80 plus 40 is 120 degrees. If you subtract it, you get 60 degrees. So what information we see here is that angle E is 60 degree and DF over here is 5 centimeter. So option B is the right answer for this question, right? Papiya, ma'am, I think it's B. Absolutely, yes, B is the answer. Hema, Pranjal says it's A. No, how can A be the answer? Because DF is 5 centimeter in both of them, Pranjal, but if you look at the angle E is 60, not angle F, because angle E and angle C are corresponding angles, right? I mean, they are the corresponding angles of these two triangles. Okay. Anuj, yes, hi. Meghraj says it's B. Deepak, B, absolutely. Ramesh, Aditi, Shreya, why not D? Why not D? Because if you see here in option D, we are given that DE is 5 centimeter, right? But if B, what we are picking here is we are picking up the corresponding parts of the congruent triangles, right? So with AB, DF is the corresponding side. D is not the corresponding side. So that means DF is 5 centimeter. If you talk about the angle over here, so angle sum property, according to that, this angle C is going to be 60 degrees. And this angle C and E are corresponding angles of these triangles. That means E should be 60 degrees. Shreya, I hope that your doubt is clear now, right? I hope you have understood. Ramesh Panwar, ma'am, you're best for me. Thank you. Vivek, yes, hi. Somili, understood. Shreya, understood. Great. Alright, so option B is the right answer for this question. Now we can move to the next one. Now in this one, we are given that in triangle ABC and triangle PQR, if AB is equal to AC, angle C is equal to angle P, angle B is equal to angle Q, then the two triangles are. Yes. Yes, Hema, you just asked what CPCT is. It's basically corresponding parts of congruent triangles. So whenever triangles are congruent, their corresponding parts are equal. So this is what we use. Anuj, your teaching is very clear. Thank you. Alright, so here we have these two triangles, right? ABC and PQR. What we are given here is AB and AC are equal. So AB and AC, if you see, they are the sides of the same triangle, right? And this angle C is equal to angle P. This is given. Okay. Angle B is equal to angle Q. This is the given information that we have. Alright. Then the two triangles are isosceles, not congruent, isosceles and congruent. Like this, we are given the four options. But if you look at all the options, we are talking about only two things. One is isosceles, another one is congruent. First, I will check whether the triangles are isosceles or not. Then I will check if they are congruent or not. Okay. So let's first see here. We know one thing, that in a triangle, when sides are equal, right? When sides are equal, their opposite angles are also equal. This is the property that I'm going to use here. The angle opposite to equal sides are equal, right? Okay, so using this property, we were given AB and AC are equal, right? So I can say that here, angle C and angle B will be equal because these are the angles which are opposite to these two sides. So using this property, angles opposite to equal sides. Make sure that you write the property in the exam. Writing the properties is important. Alright, so, and we are already given that angle B and Q are equal. Already given in the question, right? So I can say one thing from here, that angle C and angle P, this is also equal. This is also given in the question. So if angle B is equal to angle C, right, if they are equal, so I can say that angle Q and angle P are also going to be equal. Why? Because two things equal to the same thing will be equal to one another. So angle P will be equal to angle Q in that case. So if angle P and angle Q are equal, what are the sides which are opposite to them? So the side opposite to angle P is basically this QR, and the side opposite to this angle Q is basically PR, right? So here when angles are equal, so their sides will also be equal. So we'll mention the property that sides opposite to equal angles of a triangle are going to be equal in that case. Alright, so from here I can say one thing, that these two sides are equal. That means definitely triangle is isosceles. Now you need to check if they are congruent also. How will you check that? For congruency, their corresponding parts should be equal, but what we can see here is that their corresponding parts, all the parts are not equal, because AB is equal to AC. This is from the same triangle, right? Not from different triangles. But they have got these angles, this angle C and angle P is equal, this angle B and angle Q is equal. So if two angles of one triangle are equal to the two angles of the other one, obviously third angle will also be equal, but AAA is not a congruency criteria, right? So we cannot prove them congruent in that case. I can say that they are isosceles but not congruent. That's option A. Yes. Pranjal, B. No, it's not B. It's option A. Because they are not congruent. Look carefully. Yes, Pranjal, it's, okay, you are giving option B. No, it's A. Shreya, A. Pavani, A. Yes. Fantabulous Kritika. Okay, it's option A. Alright. Quickly just post it. Anush, Bitan Pandey. Yes, Anuj is there. Atul Mathur, option A. Yes, Pranjal, check your answer again, because triangles are isosceles because their sides, they have got equal sides, but they are not congruent, right? Ramesh Shukla, option A is the right answer. Jia, Alok Kumar Sa, yes, option A is the right answer for this. Okay, so we can move ahead. Now in this question, it's given that OD is the bisector of angle AOC. Figure is given. And OE is the bisector of angle BOC. OD is perpendicular to OE. Show that points A, O and B are collinear. And you can see that it's a moderate one, right? So all we need to do here is, it's very simple. Look at the keywords that we have. OD is the bisector of angle AOC. This is OD. When we say that it is the bisector, right? What does that mean? That means it's the angle bisector. Bisector means it is dividing them into equal halves. That means this angle is going to be equal to this angle, right? Alright, so an angle bisector divides an angle into two equal angles, right? So another one is OE is the bisector of angle BOC. This is OE. It is bisector of this angle. So these angles will be equal in that case. OD is perpendicular. If this is perpendicular to this OE, what you can say from here is that this angle is 90 degrees, correct? So this is the information that we have got from here. Okay, so we have to show that AO and B are collinear. Collinear means that these points are lying on a straight line. That means we have to show that the sum of the angles which are formed on this line is 180 degree. Only then we can say that it is collinear. Okay, so what I can say from here is this angle AOD, this angle AOD will be equal to angle DOC. These two angles will be equal. Why? I just explained to you that OD is the bisector. Similarly, I can say that this BOE and this EOC will be equal. Again, this is the bisector OE. That's your second equation. Now, we are also given that this entire angle is 90 because I just told you OD is perpendicular to OE. So, I can write this angle as DOC plus EOC, that's 90 degrees, right? Now, what I'll do is, I'll put these values from equation 1 and 2 in equation number 3 over here, right? So, once I put the values, what do we get? We get AOD instead of DOC. Instead of EOC, I'll write angle BOE, right? That would be equals to 90 degree. That's my equation number 4 now. Okay. Now what we will do is we will add third and fourth and we get the sum of all the angles which are formed here. So once you add them up, you are going to get 180 degrees. That means angles are on a straight line, right? They're forming a straight line, all these angles. So I can say one thing over here, that this angle AOB, this entire angle, the bigger one, that's going to be equals to 180 degrees. That means AO and B are collinear. They are on a straight line. Yes, Archana. Yes, my name is Khushbu. Deepak, what is the difference between similarity and congruency? See, Deepak, in congruency, basically all the sides and all the angles are going to be equal when we are talking about the congruent figures, right? So everything is going to be equal in them. But in similarity, it doesn't work that way. Like this triangle and this triangle, they look similar because both of them are triangles. They look similar, but they are not congruent. Their side lengths are not equal. Maybe their angles are also not equal, right? So this is the difference. There will only be similar, but they won't be equal side lengths and all. Alright, so these 3 points are forming collinear lines. Soham, ma'am, you teach so nicely. Thank you, Soham. I'm glad that you are able to understand. Atul, these angles, so they are on a straight line, hence are collinear. Absolutely, yes. Assertion reasoning? No, it's not a part of mathematics. Deepak understood clearly. Alright, so we can move ahead to the next one. Now here in this question, we are given that angle 1 is 60 degrees and angle 6 is 120 degrees. So we have to show that lines M and N are parallel. Now whenever you have to show that lines are parallel, you can see that these two lines are there, they are intersected by a transversal. How can we show that? When alternate angles are equal, or maybe corresponding angles are equal, or maybe co-interior angles are formed. That means the sum of angles on the same side of transversal is 180 degrees, right? Alright, so what I can say from here is the sum of two angles in a linear pair is always 180 degree, correct? So from here, if you look at this angle 5 and angle 6, their sum is equals to 180 degrees, right? Because they are on a straight line. Now from here, I can say that angle 6 is 120 degrees. So from here, you would get the value of angle 5. That's going to be equals to 60 degrees, right? Now since this is 60 degrees and angle 1 is already 60 degrees, I can say one thing, that angle 1 and angle 5 are equal over here. Now since angle 1, you look at this, these are on the same side of the transversal, right? They both are equal, that means corresponding angles are equal. So I can say that the lines M and N are going to be parallel since corresponding angles are formed over here. Anuj, your explanation is crystal clear, ma'am. Yes, Soham, understood. Great, Shreya, okay, ma'am. So that means that's how we can prove the lines parallel over here. Hema, these questions are really helpful. Great, Hema. Aditya, first maths was hard for me, but now it's easy because of you, ma'am. Thank you so much, Deepak. Thank you. Thank you, Aditya. Alright, so let's move to the next one. So ABC is an isosceles triangle over here with AB and AC, with AB equal to AC, and BD and C are its two medians. Show that BD is equal to CE. Now very first thing that you should think here is, it's an isosceles triangle. AB and AC are equal. These two side lengths are equal. So when sides are equal in a triangle, their opposite angles are also equal, right? We know this thing. These angles B and angle C will be equal. Another information that you get from here is, BD and C are two medians. These are medians. Medians means it basically divides the line on which it is drawn. It divides the line into exactly two equal parts. That means this BD is drawn on AC. It will divide this. So you can say that this AD and CD are equal. Similarly, this CE is drawn on AB. So you can say that this and this are equal. Correct? Alright, so first I'm going to compare these two triangles, triangle BEC, this one, and triangle CDB. And there is a reason why we are picking only these triangles, right? Because we have to prove BD and CE equal. Okay, so we have already given that AB and AC are equal, so their halves will also be equal. Why am I saying their halves will also be equal? Because medians were drawn on it. Otherwise, you cannot say that, okay? You cannot use this reason. Because it was given that this is equal to this and this is equal to this, right? So I can say that this BE would be equal to CD. Okay. Now in these two triangles that are highlighted here, you can see, we have to prove them congruent. So BE is equal to CD, because we just said that if triangles are equal, their halves will be equal. And this EBC, this angle, is equal to this, because angles opposite two equal sides of a triangle are also equal. Okay. And third thing that we can say is here is, this is the common side that they have. BC and CB will be equal. Okay, so I can say that these triangles are congruent using the property SAS congruency criteria. Now once triangles are congruent, I can say that this BD and CE are going to be equal, right? And that would be by CPCT. Why CPCT? Because when triangles are congruent, their corresponding parts are equal in that case. Deepak, two sides are equal in isosceles triangle. Yes, absolutely, two sides are equal. And these triangles are equal by SAS, not SSS. But then we cannot use SSS rule because BD and CE are not equal yet. We have to prove them equal. So we cannot use this. Ma'am, can't we take ABD and AEC? No, ABD and AEC we cannot take, reason being, if you take this ABD and this ACE, here AB and AC are equal, angle A would be common. The third thing also you need to prove them congruent. What will be the third thing, ma'am, in that case, right? The third thing we don't have here in these triangles, so that's the reason we cannot pick this up. Manimala, yes, I think you've understood this, right? That these two triangles can't be picked. Palak, it's really very useful question. Yes, Deepak. Yes, these questions are good. I told you in the beginning only, because these questions are covering your concepts, you know, in a very nice way. Manimala, okay ma'am, I've understood. Great. So it's clear to all of you. Now we can move ahead to the next one. The bisectors of interior angle B and exterior angle ACD of a triangle ABC are intersecting at a point T. Prove that angle BTC is half of angle BAC. What we need to prove here is, first focus on that. We need to prove that this angle BTC is half of this angle BAC, right? Now to prove this, first look at the keywords. What we have here, we are given that bisector of angle B and exterior angle ACD. We are talking about the bisectors. So bisectors mean here that this angle, these two angles will be equal. ACD, the bisector of ACD is also given. So this is also equal, correct? We are talking about bisectors. So whatever information is given in the question, first you should just write that down. Okay, this is all that we get from the question. Then you think, okay, what we have to prove and what all we require to prove that. Okay, all right. So we know that sum of two opposite interior angles of a triangle is equals to exterior angle. That's the exterior angle property, correct? So I can say one thing, that here this angle TBC, right, will be half of ABC. Why? Because bisector of angle B was given. Alright, and also I can say that this angle TCD will be half of angle ACD. Again, the bisector was given in the question, right? Okay. Manish, why we can't take SSA rule? You're talking about the previous question. There is no such rule as SSA. Alright. So the rules that I told you in the beginning while discussing the contents, only those rules are possible in congruency. There is no such rule as SSA. Alright. Now I can say one thing, that this BAC angle, this angle BAC and angle ABC would be equal to angle ACD using the exterior angle property. Right. I can say that using the exterior angle property, the sum of the two interior opposite angles would be equal to the exterior angle. Okay. Now in this triangle TBC here as well, I can say one thing, that angle BTC and angle TBC, look at the highlighted ones, will be equal to angle TCD, again the exterior angle property, right? Now what we are going to do here is, we can say that this BTC, I'm just substituting the value of TBC and TCD, what we got from the initial equations, right? That's half of ABC and half of ACD. Okay. So from here I can say one thing, that angle BTC would be equal to half of ACD minus angle ABC, right? If we take half common. So half of ACD minus half of angle ABC, that will actually be equals to angle BAC, and this is what we were supposed to prove. Yes, you want me to repeat one more time? Yes? Okay, let's take a look at it one more time. So what we have here is that we were talking about the exterior angle property, right? Bisectors were also given. So angle TBC is half of ABC. You can look at the highlighted part in this picture, right? Okay, and angle TCD is half of ACD, correct? And using the exterior angle property, I can say that this angle BAC and angle ABC, that will be equal to angle ACD, correct? Okay, so now what I can do here is, I can simply say that in this triangle TBC, angle BTC plus angle TBC would be equal to angle TCD, again the exterior angle property. I hope it is clear to all of you till here. Okay, so I can say one thing, that angle BTC plus angle TBC would be equal to angle TCD. I'm just substituting the values that we got from the previous equations here, right? And then I'll take half common, they will be subtracted, then we get half of angle BAC. Subin, this question was looking difficult, but you explained it very nicely. I understood it now. Great, Subin. I'm glad that you have understood. All right. So this is what we were supposed to prove in this question, right? So this was very simple. See, it was a difficult level question, but we proved it so easily. All you have to look for is the keywords first, right? Write down the information that you get from there. Okay, let's move to the next one. So this is also, you can see, a difficult level one. Let's see how simply we can solve this. So ABC and DBC are two triangles on the same base BC such that A and D lie on the opposite sides of BC, and AB and AC are equal, and DB is equal to DC. Show that AD is the perpendicular bisector of BC, right? Papiya, how ACD minus ABC is equal to BAC? Alright Papiya, first let's take a look at this. ACD minus ABC. This is ACD and this is ABC, right? So we used this equation here previously from here, from dividing it exactly, right? Perpendicular means this angle should be 90. So these two things you have to prove here, alright? Okay, now what we are given over here is we have AB and AC equal, this is given to us. DB and DC equal, this is also given, right? And they are drawn on the same base. Now using all this information, first we know one thing. We know that here in this triangle ABD and this triangle ACD that are highlighted here, you can see in blue and green, I can say one thing. I can say here that this AB would be equal to AC, this BD and this DC are equal, and this AD is common. Using the side SSS congruency rule, I can prove them congruent, right? AB is equal to AC, AD is equal to DA, and this BD is equal to DC. So I can say that these triangles are congruent here using SSS congruency rule. So these two angles over here are going to be equal, right, by CPCT. Because when triangles are congruent, their corresponding paths are equal, right? Yes. So why we needed to prove them congruent? Because we needed these angles. Why we needed these angles? Because we wanted to prove these two triangles congruent that are highlighted here in yellow. Yes. So according to that, I can say that in these two triangles, we have these two sides equal, AB is equal to AC. We have AO, this AO is common, and we have already proved that these angles over here are equal, right? So I can say that the triangles would be congruent using the SAS, side angle side congruency rule, right? Okay, so when triangles are congruent, I can say that this OB and OC will be equal, right? Because triangles are congruent, I can say that their corresponding paths will be equal. And I can also say that these two angles will be equal, correct? But I have to prove them 90 degree. How do I do that? For that, simply I can say that AOB plus AOC, these two angles would be equal to 180 degree because they're forming a linear pair over here, correct? Now, since both the angles are equal, I can write them as twice of AOB equals to 180 degree, fine? Okay, so angle AOB would be equals to 90 degrees in that case. So we have proved that these are equal and this angle is 90 degree. I can say that AD is the perpendicular bisector of BC, yeah? See, it was a difficult question, lot of information was given, but we solved it simply. Ramesh, ma'am, you are a great teacher. You don't make a video on class 8. Okay, see, Ramesh, the channel is 8th, 9th and 10th, and soon we will come up with class 8th as well. Don't worry about it. Alright, so that's how we can prove this. So I hope that it is crystal clear to all of you. Yes, Palak, crystal clear. Okay, great. So let's move ahead. So this question that you can see here is that it's a difficult one. In a right triangle, okay, this is the right triangle we have. Prove that, now this is a very nice question, just listen to me carefully. Prove that the line segment joining the midpoint of the hypotenuse, AC is the hypotenuse here, now this is the midpoint of the hypotenuse. Let's say the line segment that is joining it, right, joining the midpoint of the hypotenuse to the opposite vertex, this is the opposite vertex, right, is half the hypotenuse. Right? It's half the hypotenuse, that means you have to prove that, let's suppose this is D, so BD is half of AC. This is what we have to prove here. Okay, so what we'll do here is, we will do a little bit of construction here. Okay, so what I'll do here is simply, we will extend this BD till E such that this BD is equals to DE. Okay, now what I can say here is that in this triangle ADB and triangle CDE, in these two triangles, what we can say here is that this AD and DC are equal, right? Because it was already given that midpoint. This D is the midpoint here. See, keywords are already in the question, right? Now, one other thing we can say here is that BD is equal to DE, correct? BD is equal to DE because we showed this by construction. Another thing that I can say here is that these angles, angle ADB and angle CDE, they will be equal since these are the vertically opposite angles over here, right? Okay. Now I can say that these triangles will be congruent, right, using the SAS congruency rule. So since triangles are congruent, so these angles over here, this angle BAD and this angle DCE will be equal. Again, CPCT. When triangles are congruent, their corresponding paths will be equal, right? Okay. So these angles are equal over here. Now I can say that these angles, if you carefully look, they are forming a Z over here. Let me make a Z. They're forming a Z. Which angles form a Z? Alternate angles, right? So these are actually alternate angles. Now since alternate angles are equal, I can say that this AB and CE are going to be parallel because these were intersecting by this transversal over here, correct? Okay. So lines are parallel here. I can say that these two angles, right, they would be 180 degree, co-interior angles, because when lines are parallel, they're intersected by a transversal. In that case, co-interior angles are formed. Okay. So ABC is 90 degrees. Why? It was already given in the question. It was a right angle triangle. Okay. I have put 90 degree over here. So BCE in that case would be equals to 180 degree minus 90 degrees, right? That would be equals to 90 degrees only. So this angle over here, BCE, this is also 90 degrees, correct? Hema, ma'am, your explanation makes the question more easier. Thank you so much, Hema. Alright, so this angle BC is 90 degree now. What we need to prove here is that we have to show that this BD is half of this hypotenuse AC. Yes? Okay. So now this AB and EC over here, these are equal, right? Because we have already proved above. And also this BC and CB, this is basically common, correct? And also this angle ABC, both of them are 90 degrees, correct? So I can say that here, these triangles over here are going to be congruent in that case, correct? They will be congruent using the criteria SAS congruency rule. Now when triangles are congruent, I can say that this AC would be equals to this BE, right? Again, CPCT, when triangles are congruent, their corresponding paths are going to be equal. Okay, so AC can be written as half of EB, right? This is the AC. See, this is AC, right? I can write here. So AC and EB are equal, so their halves will also be equal. I can write half of BE and half of AC, which will actually be equals to BD is equals to half of AC. And this is what we were supposed to prove here. Yes. Yes, yes, yes. Quickly. Have you understood this? I hope that it is clear to all of you. Quickly just let me know in the chat. Yes. Papiya, yes ma'am. Hema, yes ma'am. Manimala, how many questions? This was the last question of today's session. Okay. So I think you all have understood this, right? It's crystal clear. Yes. Anuj, yes. Just visualize, yes. Manimala, yes ma'am. Great. So you've understood all the questions and you see that all these questions are covering the concepts really well, right? Shiva, Palak, Shreyanshi, Runadatta, Zora, yes ma'am. Great. Alright, so this was the last question, but it's not the end. We have lined up many more sessions for you from every Monday to Friday to make you exam ready. So we have the next session on Master Heron's Formula and Statistics, which is on November 17th, Wednesday. And the timing is same, that's 5 p.m. Yes. So stay tuned. I'll see you soon in the next session. Until then, keep learning, keep practicing. Thank you.